Okay, in this video we're going to talk about how we simplify radicals. For instance, let's talk about in this beginning page, we're going to simplify the radical square root of 200. Okay, so the first step we're going to take in order to simplify this radical is we're going to factor the radicand into its prime factors. The radicand, of course, being the number beneath the radical. So we want to take 200 and we want to break it down into all of its prime factors. And so I'm just going to start breaking out factors of this. 200 is 2 times 100. 100 is 10 times 10. 10 is 2 times 5. 10 again is 2 times 5. And so we have all the prime factors now of 200. We have 2, another 2, another 2. And we have a 5 and a 5. So we can break down this 200 into 2 times 2 times 2 times 5 times 5. All right. The next thing we're going to do is we're going to identify pairs of common factors. Okay, so right here we have a pair of 2's, and we also have a pair of 5's. And we have a leftover 2 that doesn't have a partner. Our next step, for every pair of factors in the radical, we're going to remove and place one of that number outside the radical. So since we have this first pair of 2's, we're going to bring a 2 outside the radical. And then since we have a pair of 5's, we're going to bring a 5 out in front of the radical. And whatever doesn't have a partner, we're going to leave inside the radical. So since we have this 2 right here without a partner, we're going to leave a 2 inside of the radical. And then our last step, we're going to multiply all the factors both inside and outside the radical and write our final answer. Well, we have two numbers outside of the radical, 2 times 5. 2 times 5 is 10. And we only have a 2 inside the radical, so we don't need to multiply that times anything. And there we end up with our final simplified form of the square root of 200, which is 10 square root of 2. A note for you, this is what is known as reduced radical form. So anytime you see something, if you've got a radical and it says, simplify to, reduced radical form, this is what your answer should look like. It shouldn't be a decimal or anything like that. It should be in this reduced radical form. All right, let's do a few more examples to get this concept under our belt. First, we're going to simplify the square root of 24. So the first step that I'm going to take in simplifying this is I'm going to take 24 and I'm going to break it down into its prime factors. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. And so square root of 24 is equal to the square root of 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. Right? You want to make sure you're really careful when you do the prime factorization with a factor tree. You want to make sure, first off, that you break it down entirely into prime numbers that are not divisible by any other numbers, and also that you are careful in getting all the factors from your factor tree back into your radical. Okay, now we've got a pair of 2's here, and we have a lonely 2 that doesn't have a partner and a lonely 3 that doesn't have a partner. So they're going to stay inside the radical. Pair of 2's, I bring 1 out. 2 and 3, I leave inside. And now I multiply any numbers that are outside the radical and any numbers that are inside the radical. And there's my reduced radical form for square root of 24. All right, simplify the square root of 80. Again, we start with this number and break it down into its prime factorization. 80 is 2 times 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So we have a 2, and another 2, and another 2, and another 2, and a 5 as our factorization for 80. And now again, we're going to identify pairs. We've got a pair of 2's, a pair of 2's. For each one of those pairs, we're going to bring 1, 2 outside of the radical. So there's a 2 for the first pair, a 2 for the second pair, and we're left with this lonely 5 inside here. And now we multiply everything that's outside, and we multiply everything that's inside. And there's our reduced radical form for the square root of 80. All right, let's do another one. Simplify the square root of 45. So we're going to find the prime factorization of 45. 45 is 5 times 9. 9 is 3 times 3. And so this is the square root of 3 times 3 times 5. We look at this and we identify. We've got one pair of 3's, so we bring a 3 out, leave the 5 in, and now in this problem there's nothing to multiply back together and recombine. We're already at our reduced radical form. And our last example from this video, we're going to simplify the square root of 33. We do the prime factorization of 33. 33 is 3 times 11. 11 doesn't break down anymore. And in this case, we don't have any pairs. We've got a single 3. We've got a single 11 in there. They don't have any partners to pair with and bring outside of the radical. So they both stay inside of the radical. And now we're just going to multiply things back together to write the reduced radical form. And in this case, square root of 33 is already in reduced radical form because there aren't any factor pairs when we break it down into its factor tree. And so there's nothing that we can take out of the radical. All right, that concludes our video on simplifying radicals.